Incidence graphs are also known as causation or Levi graphs. They show how manipulating the controllers involved can change how the process proceeds. These controllers include things like heat exchangers, temperature and pressure sensors, and many other devices needed for chemical processes.
Monotonicity takes place for an ideal system in which changing one variable would lead to predictable changes in the other variables. On the left is a graph showing monotonic increase, where increasing one variable would always increase the other. The graph on the right shows monotonic decrease, where increasing one variable would decrease the other.
A controller that doesn't give predictable changes in variables is considered a non-monotonic system, like the sinusoidal wave indicated in the graph. If more than one controller inputs to the same variable, we would not always know how that variable will react.
Traversing is a path that shows the relationship between the two controllers. The arrowhead bar indicates that the resulting node moves in the same direction as the initial one. However, the perpendicular bar indicates that a change in the resulting node moves in the opposite direction as the initial one.
For example, with the perpendicular bar connecting nodes 1 and 2, an increase in 1 will lead to a decrease in 2. With the arrowhead bar connecting nodes 2 and 3, an increase in 2 will lead to a similar increase in 3. For the path 1, 2, 3, an increase in 1 will lead to a decrease in 2 as indicated by the perpendicular bar. This decrease in 2 will also lead to a decrease in 3 because of the arrowhead bar.
There are three types of pathways, the first of which is described by consistent graphs. Using the same method as described in the previous example, the results of the different pathways are shown in the table on the right. As you can see from all pathways, node 4 has the same outcome, which is a decrease. This illustrates redundancy, which allows the system to be monitored by several different controllers. So, if one controller fails, the desired outcome can still be obtained.
The second type of pathway would be described by the inconsistent graphs. The results in the table clearly show that different pathways yield different outputs. For example, in the pathway 1, 2, 4, node 4 shows a decrease as opposed to an increase in the other two pathways. This illustrates feedback control, which helps the system by repressing it so that it will not be overstimulated.
The third type of pathway is described by the partially consistent graphs. These graphs have both consistent and inconsistent pathways. There is a consistent pathway between nodes 1 and 4 because an increase in 1 will always lead to a decrease in 4. However, the inconsistent pathway between nodes 1 and 2 yields different outcomes for node 2, as shown by the increase in path 1, 2 and a decrease in path 1, 4, 2. A partially consistent graph indicates a system that uses redundancy and feedback control.